Okay, what is this? This is a solar powered supercapacitor charger thing. So what I did was I went to Michael's and I bought this wooden box, and then the box has a magnetic kind of latchiness to this. I drilled a hole here, put a switch here. Drilled a hole here, put a USB thing. It has little hangers things on the back for it, which is nice. So if you open this up, if I can get it, there we go. So you open this up, it just pulls open. It's got little magnets on this ridge here. And then what I did was I glued a bunch of 1.5 volt solar panels to here first, and then put hot glue down between all of them, ensuring they're not electrically touching, because sometimes these panels have like little side contacts. And then soldered all the negative leads together, the black wires, and then I soldered all the red leads to Schottky diodes. Okay, so it'll come out of the one red side, go into a Schottky diode, and then go to some point, and they're all in parallel though, they're not in series. So what this does is this each panel here is 1.5 volts. Now in direct sunlight, they can get up to 2.5 volts, I think, something like that, which is bad because these capacitors, these supercapacitors, are only supposed to go up to 2.7, and so you don't want that. You don't want it getting close to the threshold of one of these caps. So started at 1.5 volts, and then I bring it down to 1.2 volts, and they're all in parallel. So it's a lot of current, not a lot of voltage. That goes down here into the super cap bank. Has a whole lot of supercapacitors. Each one of these, I think, is 100 farad cap each. 100 farads. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in total, this should be 1,200 farads. Then I soldered. Look, I can touch and I don't die. Wow. You know why? Because this is only 1.2 volts that it charges up to. So then I soldered the positive and negative leads together for all those. All those are in parallel. And so this is only at 1.2 volts. And then it goes through the switch here. And then that goes through only one 0.9 volt to 5 volt voltage booster that then goes out to a USB thing. Okay, so then you can plug in a normal USB device like this into the side, and then leave this out in the sun for, I think, a day. Charges this up. But this voltage booster only provides 5 volts at 200 milliamps max. That's what it says. So that's not a lot of power. So if you try to charge your phone in here, it won't work. What it can do is it can run small USB devices that don't take a lot of power, like LEDs or, I don't know, little tiny fans, or I don't know what else you would run. So mainly I'm just using these as basically a solar powered flashlight. That's kind of what it is. But because it's 1,200 farads, when you turn it on, it will run for like 2 days like this. And then but so let me talk about the benefits of this. Is you do not end up with a lithium-ion battery, which goes bad. Typically, in 2 to 5 years, lithium-ion batteries go bad. Instead, now you're using supercapacitors, which go bad in about 300 years if you use them properly. If you don't use them properly and you go close to above 80% of the maximum voltage listed on the capacitors, then they will start slowly deteriorating, or if you go way over that, then they might just explode or something. So yeah, you don't want to do that. But if you keep below the threshold of these will last for 300 years. So if you're looking for a real emergency solar storage device that you won't have to check every year to ensure that the lithium-ion battery isn't dead because you left it plugged in and it wasn't supposed to be plugged in all the time, or because you left it in a closet, then this has some usefulness. And what you can do is you can leave it up or hang it up against your window. So this is facing the window. There's no way this is going to overcharge. It will get up to 1.2 volts, or in full sun, maybe 2.2 volts. I think max on those capacitors. If it was like just really bright. And then you have this light facing your room that you can use in an emergency scenario. And so this is a real emergency device, and not something that has to be constantly checked every year. Theoretically, you could just, if there were some problem, then go out and use a solar panel to charge your phone, right? But what if it's dark and then the power goes out in your house? Okay, then that needs to be stored somewhere, but you want to store it on something that's not going to go bad every year and that you have to replace every year. All right, I'm done talking about this. Goodbye.